Hey, this is Ahmad from Corgea. Many of you have asked us to show you findings that BLAST typically finds that most SAS scanners struggle with. BLAST is our AI-powered code scanner. It can find business logic and code logic flaws and traditional SAS findings. As you can see here, we have Node Goat, which is a vulnerable application. The CWE that's been found is a weak password requirement. What's novel about this finding is this finding typically shows up at the time of a pen test. So usually humans find this type of vulnerability, but Corgea found it in the code. And as you can see here, because Corgea leverages LLMs as part of its scanning technology, it understands the semantic context. It can read comments and understand the intent of what the application is doing. So as you can see here, the regex for password requirements is only 1 to 20 characters. That's the minimum password requirement, and Corgea understood that here. And so what Corgea is proposing, it fixed it by uncommenting the existing regex that is in here. It understood that this is a more valuable regex, uncomments it, and provides a more appropriate fix. This is the type of vulnerability that usually gets catched in production, but we caught it at this time. Let's see another vulnerability. This one's even a bit more nuanced. As you can see here, we have a use of a broken or risky cryptographic algorithm. Most SAS scanners today will look for this MD5 word as a bad pattern, right? And Corgea found the same thing. What makes this novel and unique is Corgea doesn't look for any MD5 use. It looks for it in specific contexts. MD5 can be used in very safe way in non-security related activities, right? But in this particular scenario, we see we're using it for password hashing. That's pretty bad. We shouldn't use that. And you can see Corgea understood that. The code uses MD5 algorithm for password hashing, which is considered insecure and outdated. And as you can see, Corgea wrote the fix using password hasher. Why did it use password hasher? If we look at the full file, you can see here we're actually importing Argon 2's password hasher, which is specifically purpose-built for these types of applications. And so not only did Corgea find the vulnerability, it found and recycled existing functionality that's been used elsewhere. And if you look at the full code, you would see that it's actually being used, right? The final one that I wanted to show is in this application. This is Node Goat again. And you can see missing encryption of sensitive data. As you can see here, social security numbers and dates of birth are not being encrypted in storage. And as you can see, sensitive data like SSN and date of birth, you see, again, Corgea understands the intent and the semantic and context of what the application and the code is trying to do, are stored without encryption, risking exposure if accessed by unauthorized users. And you can see this actually understood what's going on. And the fix here encrypts sensitive data, and as you can see, it used the fix that's being proposed and was commented out. Often developers might actually know where the vulnerabilities are and might actually leave a comment in there and might actually put a proposed solution. So Corgea is able to read some of these, find them, and use them. And so this is just a small example of how BLAST can help you find and detect what was previously undetected. Thank you.